I'm sure you already have a pretty good everyday understanding of what dilution is. You take one thing that's fairly concentrated, you add some solvent to it, and it becomes less concentrated. You might say that it became less strong, but avoid that language at all costs in chemistry because strong and weak are going to have very specific meanings in chemistry, and we'll see that in separate videos. So dodge the words strong and weak, focus on concentrated, less concentrated. Now, just think through what you would do there. If you had some concentrated red food coloring, you would add some solvent to that, some dye, some water. And you'd end up having that very concentrated solution of red dye turn more dilute, right? Well, since we can write down that original concentration like this, we could say it's going to have some concentration, which is going to be molarity. And we know that molarity equals moles divided by liters. We can also rearrange that, though, because what we're going to do is we're going to change the amount of liquid that's around it and see how much the concentration changes. But we're not actually going to remove or add any extra solute, the thing that we're dissolving. So let's rearrange it to have it by itself. We'll write moles equals molarity times volume. All right, so molarity times volume. In fact, instead of saying liters, let's go ahead and keep it in the actual variable. Molarity times volume equals moles. And we're saying that we're not going to have any of these moles removed. However, we can end up having it in a larger or smaller volume. So you can kind of think of this as being a before and an after process. And sometimes people will use initial, like a subscript I, and a subscript F. Or they'll put the numbers 1, 1, and 2. The key here is you want to make sure that you keep the two values that are related together. So if I tell you that you've got a 1 molar concentrated solution, and you take 1 milliliter, those two facts have to stay together. They're both going to be over here on your initial side. You then dilute it to be 10,000 liters, or something bigger, or smaller than that. That would be over on this side, and you're going to calculate the new volume's new molarity, or vice versa. But make sure you keep those two facts conjoined, and you put them on the right side of these equations. Now, we can use these kind of relationships to determine the concentration if we're diluting something. We can also use it when we're concentrating something by evaporating off the water or something like that. So make sure that you're careful in using this equation the correct way. M1V1 equals M2V2, or MIVI equals MFVF, if you like initial and final better. You don't need to write the word mole in the center, but it's not a bad idea to do it either, because it reminds you that what you're doing is you're saying the same number of moles that you started with are still present at the end. All that you've done is change how big of a space it has by putting more or less solvent in.